Good day, everyone, and welcome to our forum. I am Edilgo as the moderator for today's forum. Today, we'll be discussing wireless electrical vehicles charging, a technology that uses electromagnetic principles to transfer energy without physical cables. As the world moves towards sustainable transportations, electrical vehicles or EVs are becoming an important solution to reduce carbon emissions. However, EV technologies also bring challenges, especially related to battery productions, environmental impact, and electromagnetic safety. In these forums, we'll explore how wireless EV charging work, its sustainability benefits, possible risks, and the engineering solutions needed to make this technology safer. First, let us hear from our technology expert Isaac about the electromagnetic concepts behind wireless EV charging.
Thank you, Mabel. Imagine driving your electric vehicles without ever stopping to charge. No cables, no charging stations, just the roads beneath your power, your journey. That future is closer than you think, and it's made possible by electromagnetic waves. Wireless EV charging works based on the principles of electromagnetic induction, specifically using a method called resonant inductive coupling or magnetic resonance. This technology usually operates at low to medium frequencies around 85 kHz. The system consists of two main components. The first is a transmitter coil, which is installed under the road or charging pad. The second is a receiver coil, which is placed underneath the electric vehicles. The process starts when an alternating current flows through the transmitter coil. This creates a continuously changing electromagnetic field around the coils. When the EV is positioned above the charging area, the receiver coil experiences a change in magnetic flux. According to Faraday's law, a changing magnetic flux produces an induced voltage. This voltage generates electric currents, which transfer energy from the road system to the vehicle batteries. In simple terms, electric energy is converted into an electromagnetic field, transferred wirelessly, and then converted back into electrical energy to charge the EV. This technology has the potential to create dynamic wireless charging roads, where EVs can charge while driving instead of stopping at the charging stations. However, like any technology, we must also consider its sustainability and safety impacts. I'll now hand it over to my fellow panelists to explore those dimensions further.
Thank you for the explanations, Isaac. Now, we will discuss how wireless EV charging contributes to sustainability by Haidia, our sustainability champion.
Thank you, Mabel. Wireless EV charging can provide significant benefits for sustainability, especially in the transportation sector. The electric vehicles depend on large lithium-ion battery to store energy. However, producing this battery requires materials such as lithium, cobalt, and nickel. The mining process can cause environmental problems such as habitat destruction, water pollution, and increases carbon emissions. Wireless charging, especially dynamic charging systems, can reduce this problem. A vehicle can continuously receive energy from charging rods. It may not need extreme large batteries. In the small EV battery in the future, EV batteries could potentially become much smaller and lighter. Smaller battery means less demand on raw material mining, lower carbon emissions during battery manufacturing, less battery waste at the end of its lifetime. Besides environmental benefits, smaller batteries can also make vehicle more energy efficient because they carry less weight. Therefore, wireless EV charging can support the transitions between cleaner transportations and a more sustainable future.
That sounds promising. However, every technology has possible challenges. Let us now discuss the safety and environmental concerns from our expert study.
Thank you, Mabel. Although wireless EV charging provide many advantages, there are several concerns that must be considered. The first concern is the effects of continuous electromagnetic field. Since wireless charging road generate electromagnetic fields under public area, there are questions about the impacts of long-term exposure. For example, passenger inside vehicle or individual with medical device such as pacemaker may require extra protection from electromagnetic interference. Another concern is stray electromagnetic field. If electromagnetic energy leak outside the intended charging area, it could interact with nearby objects. For example, metallic objects such as aluminum can or metal debris on road may experience induced current. In extreme situations, this could create unwanted heating and become a possible safety risk. There is also the issue of electromagnetic interference or EMI. Strong electromagnetic fields may affect nearby electronic system, communication network, or sensitive equipment. Therefore, while wireless EV charging is promising, engineers must ensure that the technology is safe for both human and the environment.
Thank you for highlighting those concerns, Yuredi. Finally, let us invite Michelle, the solution architect, to explain the solutions.
Thank you, Mabel. To make wireless EV charging safer and more sustainable, engineers can develop several solutions. The first solution is advanced electromagnetic shielding materials. Shielding materials such as aluminum plates and high-permeability ferrite materials can be installed around the charging system. This material helps control the magnetic field direction and reduce electromagnetic leakage. For example, shielding can be placed under the vehicle chassis and inside the cabin floor to protect passengers from unnecessary electromagnetic exposure. The second solution is the use of smart intermittent activation grids. Instead of keeping road charging coil active all the time, sensor can detect when an authorized vehicle is directly above the charging area. The charging coil will only activate when needed. This reduces unnecessary electromagnetic field generation and improves the energy efficiency. Another improvement is using intelligent control systems. This system can adjust charging power based on vehicle position, battery condition, and energy demand. By combining smart technology with renewable energy source, wireless EV charging can be more efficient and environmental friendly. As engineers, our responsibility is not only to create new technology, but also to ensure that it benefits society safely.
Thank you to all panelists. From today's discussions, we learned that wireless EV charging use electromagnetic principles, especially resonance inductive couplings, to transfer energy without cables. This technology can contribute to sustainability by encouraging EV adoptions, reducing battery size, and lowering environmental impact. However, challenges such as electromagnetic exposure, energy losses, and infrastructure costs must be carefully managed. Through battery engineering solutions such as shielding materials and smart activation systems, wireless EV charging can become a safer and more sustainable transportation technologies. Thank you everyone for joining our forum.